Okay, so my first question is, we started off in much the same way between these two questions, right? We start off here for this question, and we started off here for this question. Same premise, we're trying to work out the same thing, R, right? Why do we end up with one solution here and two solutions here? Can anyone explain why we have two solutions at all?
Can we explain why it works or why they have?
We will get to why it works. We will get there. But I'm just trying to work out how, from the same starting point, does one come with one solution and one comes up with two? Yeah, James.
Would it be because
You've got the same denominator. So you've got 1 minus r here, and you've got 1 minus r here. But what I'm suggesting is, shouldn't that mean they would be similar? Like if I got one solution here, I'm expecting one solution over there as well, because they're similar, right? So that is true, and the answer is actually something to do with the denominator. But can anyone else see, like, why do we suddenly get two solutions?
Because if we have divide by, you have to. It's the
You stop. Think first, speak second. What are you thinking, Jesse? We started with, what did we start with?
We had the second term.
Right, this has to do with the first term, doesn't it? Right? Now, what we defined was the second term, but in order to use this limiting sum thing, right, you do have to go back to the first term. You actually always have to use it, right? Because it's a on 1 minus r, not term 2 on 1 minus r, right? Now, in order to go back to the first term, from 6 you have to introduce 6 on r, right? So this is no longer a constant like we had here, which we could just cancel out, okay? You're getting a fraction. Now, can you see why that's the problem?
Yes,
which line?
If you rewrite s as 2 over r minus r times 1 minus r, and 1/3 and 2/3 are 1 minus each other.
They're kind of like conjugate sort of things.
Yes.
Yeah, okay, all right. Let me see if I can unpack that a little more. Which is the critical line? Because there's a line where it goes from having one solution, or it looks like it has one solution, and then it clearly has two solutions. Where does it transition? From here to here?
Yes.
Okay, now even at that point, I think it's still a bit unclear. It could still have had one solution, right? I think where it really becomes clear is actually from here to here. Can you see why? Right? Because this is where we introduce a quadratic. This is when it becomes a quadratic, and that's when we start to factorize, right? In reality, like, it's all the same equation. Okay, so me talking about which step is which is kind of a bit trivial. But well, this is where we multiply by r. Now, think about that, right? You know when I give you a this is where I did it, isn't it? If I gave you an equation like this, right? How many solutions are there?
Two.
There are two, right? And you can automatically almost see that it's because degree 2, yes? Now, one of the things we learn in like year 8, 9 is even though you could divide through by x, you shouldn't do it, right? Even though you end up with a true statement, why don't we do it? You lose a solution, right? You eliminate one, right? Going from degree 2 to degree 1, you lose a solution. Therefore, we ought to expect that at this step here, when you go from degree 1 to degree 2, it's not really degree 1 because you got the fraction, but kind of degree 1, that's when it becomes clear, okay, there really are two solutions. Okay. Now, what do we come up with? Do they both work? Does one work and the other one doesn't? They both work. They both work. So this is interesting, right? You gotta be careful. You know, we've looked at lots of places where you solve a quadratic, but then you have to exclude one of the solutions. Come in.
This is for just the one.
Thank you. I'll hold it. All right. Sorry, where was I? Quadratic equation. You end up with one. There are two solutions, but often you have to exclude one. Okay. But let's test this out. Let's see what happens. Because don't forget, both of these are within the domain restriction that we set before, namely this. Okay, so it should work, right? Let's try the first one. R is equal to 1/3. I'm going to get rid of this because this is not the same question. Now, what was the original question? We're trying to work out the first three terms, right? the second term is always 6. So what should the first term be?
6 on one of those.
If the ratio is a third, right?
6 on one of
It's going to be, to get from this term to this term, I multiply by a third, right? So I should have 18, yes? Plus, what's the next term?
Wait, don't you? Alright, 2.
2, right? And so on. But those are the 3 I want, okay? Now what happens? Let's test this out. This should be equal to, this is the limiting sum, right? So it should be 18, that's the first term, on 1 minus a third. Sorry, 1 over 3. Okay? 18 divided by 2/3. That's gonna, the 3's gonna come on the top, 54 divided by 2. Sure enough, it works. Okay? Let's test out the other situation. What if it was 2/3? The second term is still 6. What's the first term?
Where is it? 9.
It's 9 because 6 is 2/3 of 9. Right? Next term is 4 and so on. Okay? So, what's the whole sum meant to be equal to? Well, it's A on 1 minus R, okay? Which is 9 on, which is 9 divided by a third, which is 9 times 3, which is 27. Okay, so it does work. Now, just visually, sort of what's happening, this series, it starts bigger, doesn't it? It starts twice as big. But it shrinks faster, doesn't it? Right? Because the ratio here is smaller. That's why by the third term this is 2 and this one is 4. This one starts smaller, but it shrinks more slowly, so that's why they end up at the same point. Okay? Now you'll need to watch out for this later on. When you get down to this point, you're solving for generally the common ratio, okay? Sometimes both will work. Sometimes only one will work, and you have to check it out, okay? Watch out for this domain. It's going to come back and bite you again and again if you forget to look at it, okay? But that's how question 11 kind of plays out, okay? So if you get to that, part C, part D, part E, and you have more questions, let me know. I've actually got the answers already worked out, but I think that's enough. You get the idea. Okay. Thank you.